Hey, this is Ken Rosever. This question was sent to me by my wife's aunt, and I thought I'd record a video. So, the area of a right triangle is 36 centimeters squared. It's the first piece of information that we have. So let me attempt to draw a right triangle here. And all we know about this right triangle, not drawn to scale, just that it's a right triangle, is that its area is 36 centimeters squared. Alright, leg XY of the right triangle is twice as long as leg YZ. Alright, so that means the longer leg, XY, is 2 times the shorter leg, YZ. Because the legs come out of the right angle, we know that XY and YZ are the legs, so Y must be the right angle. What is the length of XY? So we're not asked to find the hypotenuse or anything, so we won't have to use Pythagorean theorem. We just have to basically dissect this sentence and turn this sentence into an equation and then put the two together. So the first thing we notice is that it's a right triangle, yes, but more importantly, it's a triangle in general. And the formula for the area of any triangle, we'll say the area is 36, but the area is always 1/2 the base times the height. So I have that. On this triangle, my base is XY, my height is YZ. So up here, when they say leg XY, that's B. That's my base. It is means equals, twice as long as YZ, 2 times H. I'm trying to find XY, which is the base. So I'm going to do what's called substitution here. I'm going to take this equation, which tells me that B is equal to 2H, and I'm going to plug, actually I'll just plug in for B here. If I replace B with 2 times H, then I get this equals 36. And then the 2's will cancel out. And we get that the height squared is 36, which means that the height is the square root of 36, which is 6. It could be plus or minus 6 technically, but you can't have a negative height. So we'll just call this as 6. Well, now we know that the base is twice the height, 2 times the height. The height we found was 6, so the height is 12. You could also take this 6 and plug it into our original equation, which was 36 is 1/2 base times height. We have 1/2 B times 6. I know that's confusing. I have a B and a 6, but this one's a 6, equals 36. If we double everything, actually we can use associative property here. That's even better. Where'd my pen go? There it is. If I use associative property, then I can swap these guys, because A times B times C is the same as A times C times B. So I'm going to go 1/2 of 6 times B. 1/2 of 6 is 3, so I get 3 times B equals 36. And when you divide both sides by 3, you get that B equals 12. So either equation you plug back into, you're going to get the base is 12. Why did I choose to plug back into this one? Because it's the easier equation to work with. Alright, I'm going to show you one last thing. I hope that makes sense. And then I'll make up another problem that's similar and we'll try it out. It might not come out so pretty because I'm making it up, but we'll see. So actually I didn't want to erase that. I wanted to erase all this. In this problem, I chose to sub in for b and replace it with 2h because I saw up top that the base was twice the height. Okay, but alternatively, when you have an equation, I keep losing track of my pen. When you have an equation like b equals 2h, and it's b that you're trying to solve for, what you really want to get rid of in this formula is h. So you could actually go like this. Divide both sides by 2, and you get that the height is half of the base. And then you can replace in this equation, you have a 1/2 b times another b over 2. So that's b over 2 times b over 2, which is b squared over 4. If you multiply both sides by 4 to get rid of the fraction, you get 36 times 4. And over here, the 4's cancel. And 36 times 4 is 144, which is b squared. And the square root of 144 is 12. If you didn't have a calculator available to do 4 times 36 and you didn't feel like multiplying it out, you could actually leave it in this form, because if you take the square root and the square root of 4 times 36 is the square root of 4 times the square root of 36. So you get 2 times 6, which is 12. So either way, you get the base is 12. So actually what I'm saying to you is, because you have two equations and each equation has two variables, you can make 4 selections of which variable to solve for, and then you would plug that into the other equation. So there's a lot of different ways to do this. But any way you slice it, if you set it up correctly, as long as you do the substitutions correctly and the subsequent algebra, then you should get the same answer for the base being 12 and the height being 6. Alright, let me make up another one. Suppose the area of a right triangle, they don't actually have to tell you that it's a right triangle, but the area of a right triangle is 30 square inches. If the base has a length that is 2 less than, actually let me go 8 less than 3 times the height, find both the base and the height. Alright, so let's suppose we had that problem. If you want to try it on your own, pause the video here and do so. Otherwise, I'm going to do it right now. You should really try it on your own first, though. The area of a right triangle is 30 inches. Area of any triangle is 1/2 base times height. The reason for that is because any triangle is half a parallelogram, and the area of a parallelogram is base times height. Alright, so now we have 30 is going to be 1/2 the base times the height. If you don't like the fraction in front, you can double everything. 2 times 30 becomes 60. 2 times 1/2 cancels out, and you get 60 is base times height. Alright, the second sentence says if the base so has a length that is 8 less than 3 times the height, is 3 times the height minus 8. Find both the base and the height. Let me clean that up a little bit. Alright, so that is this if statement translated. It's translated into an equation. Because I have two equations now, I should be able to plug one into the other and solve. So 60 equals b times h, and I'm going to plug this in, b times, oh wait, b is what I'm substituting in for, right? So I'm going to plug in what? In here I'm going to have 3h minus 8 times h equals 60. Now this problem is a little more difficult than what you were given. But using distributive property here, we get 3h squared minus 8h equals 60. And then if you move this to the other side, the 60, it becomes this equation equals 0. So you want to find a h such that this polynomial equals 0. And this is actually where and why we learn factoring. Because if we can factor this into two factors, or if we use the quadratic formula, we can solve this and find h. So that is another lesson. So what I will simply do here is I'll use the quadratic formula. For any equation of the form ax squared plus bx plus c equals 0, x will always equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And so unfortunately, when I did this problem, I didn't realize I would be making a quadratic, but now we have one. So how do we solve it? We take this to be a, negative 8 to be b, and that to be c, and we plug it into this equation here. Of course, x is h. So h is equal to negative 8. Oh, wait, it's negative b, so it's negative 8 plus or minus the square root of negative 8 squared, because it's b squared, minus 4a times c all over 2 times a. And hopefully this will come out to something nice when we simplify it. Plus or minus, this is 64, minus, but minus minus is plus, and then we're doing 12 times 60, which is 720, plus 64 over 6. So it's going to be 8 plus or minus the square root of 784 over 6. The square root of 784, I'll just use a calculator, should be less than 300. It's 28. Or less than 300. I meant less than 30. It's 28. So we get 8 plus or minus 28 over 6. 8 plus 28 is 36 over 6, which is 6. And 8 minus 28 over 6 is negative 22 over 6, which is negative 11 over 6. And this is a solution to this quadratic up here. However, because the height in here is on a triangle, you can't have a negative height, so your height is 6. You have to take the positive answer. And if the height is 6, going all the way back to the top, then we had this equation. And if you plug in 3 times 6 minus 8, that's 18 minus 8 is 10. And so there you go. You get the base and the height. I apologize that I did one with a quadratic, but there you go. There's another example. The challenge is to write the equations, to substitute one into the other, and then to have the right techniques available to solve the resulting equation that only has one variable in it now, algebraically. I hope that helps. I don't know if it does, but in any case, this video is done.